let's look at question 2 from week 2, and it's a depreciation function, meaning how a hard good is reducing in value over time, and that's true of cars or equipment that you might have for your office, photocopiers, and so on. So the question reads, the manufacturer's suggested retail price for a base model of 2016 Toyota Prius is $25,035. It's expected to be worth $14,115 in 4 years. So we are to find the formula for the linear depreciation of this car. So just the very idea of something that's linear means that we're looking for something in the form y equals mx plus b, where m is the slope or depreciation for this function, and b is the y-intercept, which occurs when x equals 0, b is the y value. So we can look at our question. We've got 2 points given. We have $25,035, and that is the price now, so today. So that would be a point of 0 and $25,035. And we have a second point, which is 4 years and 14,115, where x is the number of years and y is the value. So 4, whoops, there we are. So the first thing we can do is find the slope of this function by using our formula y2 minus y1 over x2 minus x1. So we're looking at how this function goes up over distance. So we're looking at rise over run. Rise divided by run. That's what we're looking for here. And what we will know, or what we can predict, of course, is that a car depreciates or goes down in value, so the slope is going to be negative. So let's substitute our numbers. We have 4 minus 0, and we have 14,115 minus 25,035. And that gives us a value of $2,730. And so that means that the decrease in value occurs at a rate of $2,730 per year. So we can now find our b value, our y-intercept. And we could plug a point in for x and y. We have 2 points, and we could establish what b is. But we know that b is the y value when x is 0. And we have to see that we already have that point. We have 0 and 25,035. So 25,035 would be our b, or our y-intercept. So our function is going to look like this. Y is equal to negative 2,730x plus $25,035. So now with this linear depreciation function, we can estimate the value of this car some years down the road. In the case of question part B, it says to find the value 5 years from now. And we can also determine at what rate this car is depreciating. And I'm going to take it to the next page. Part B of this question asks us what the value of the car will be 5 years from now. So there's a couple of ways to approach it. We already have the value of the car 4 years from now, and we also know how much that car depreciates every year. So we could take that value and subtract it. Another way we could approach it is by substituting x is 5 into the linear depreciation function and solving for y. And of course, either way you would like to do this question, of course, you're going to get the same value. So the car will be worth $11,385 in 5 years. And again, we know for Part C that the car is depreciating at a rate of $2,730 per year. The slope of the function is the same as the depreciation rate, and so that would be $2,730.